This is my Hobbymat 65mm drilling machine, and I've now completed all the work that I need to do to fully electrify the lathe so that I can make more use of it than I would do otherwise. The main issue with the lathe when I got it is that the main axis, the x-axis down the lathe, had a handle at the end, and this pitch of this screw is 1mm pitch, and it takes an awful lot of turns to move the carriage slightly from one place to another. So it clearly needed to be electrified so that it could move. So I fitted a stepper motor at the end here, which is a NEMA 23, but one of the larger size of those. It's a 4.2 amp 3 Newton meter torque motor from Stepper Online, and it seems to work perfectly well. It's reasonably soft in its characteristics, which is a good thing for operating something like this. It has fairly sharp switching. Inside the cover here, that's just a loose cover to hide it. There's a Lovejoy coupling, which is the same as the Lovejoy coupling I've got on the main spindle for the mill. Let's pop that back on. I haven't had to do very much to the lathe. It was all in quite nice working order, just needed adjusting, that was all. I've made a series of tool posts which have included a number of extras that I've made. I also made up a threading attachment that makes it a little easier to do the threading, and a combination of that and the computerized gearbox threading makes this a very versatile lathe. Turning threads is absolutely no problem at all for any size or any pitch. This is one that I've just turned as a practice job, 10mm for a standard screw, which is 1.5mm pitch, and I had no problem turning that. That's in aluminium, but I can turn steel, stainless steel, with the normal tool, so cutting a thread is no problem either, provided it's not done with cutting huge depths of cut at the same time. Now, let's just move this a little bit. At the top of the bill I've got a wiper motor up here which has a gearbox attached to it, and the shaft of the gearbox lines up exactly with the pre-existing shaft, and that has, as I said, a Lovejoy coupling that allows that to be connected directly, and that works very well. It just allows me to, it's got enough of a reduction in the speed of the motor to give me good control over the movement up and down. I'll go through that in a little more detail later. The motors that drive the lathe I've changed now for 500 watt motors, 26 amp motors, and they are for driving a scooter, and they only need some fairly modest pulse width modulation control to control the speed of them quite easily. So I've got speed control over this motor here, speed control over the motor inside here, and this one, the stepper motor, that's controlled via this speed controller here, and I've got a stepper controller board inside here, which is a bit difficult to show, but I will try and get it opened up so you can see it. And there's a electronic gearbox which I saw on the internet, which a French gentleman had done the programming, and I've been corresponding with him to get it to suit this particular lathe, and he made one small alteration to the software which has transformed it now. So what it does is it runs forward however many millimeters you set, and then you can retract the tool with the retracting mechanism here, and then it flashes to tell you that it needs to move up, or move back. And when it moves back, it has to take account of backlash. So it moves back, stops, and then moves forward a couple of millimeters, and it's then in a position to cut the next cut. And I have found that this is absolutely 100% accurate. I've had absolutely no problem cutting the thread accurately, and even without a gutter at the beginning and the end here, it will cut a thread and stop in exactly the right place. The linking of this to the software is via a indexer which feeds back a signal into the board via the wire here. So I've got two methods now of using the stepper motor. I can either use it in a semi-manual method here, so that's on and off, and that's left and right, and this is the speed which it goes left and right, and that's more intuitive, I feel, than using the buttons on the software of the French provided system. So I can switch from one to the other, so I can go from manual mode using these controls, or the electronic controls on here, and all of the motors are reasonably low power, so I've got quite a lot of transformers here. I've got 24 volt transformers running the motors here and here, and obviously the one behind here, that's a 24 volt motor, and the software that runs the stepper motor and the stepper motor driver, that's running at 48 volts. So one of the transformers is 48 volts. So what I can do now is to show how some of this works. I think I'll start with the threading, so you can see how nice that is, and very simple and quick to use. It's probably the most simple system I could think of, really, and the controlling of this electrically is pretty intuitive. It's still possible to make a silly mistake, and I do occasionally. I've got an on-off button on the spindle here. This one at the moment, it should have had an on-off button there, but I haven't got space to fit it, unfortunately, so it relies on the switch on the potentiometer. This one, they both die off to nothing when you turn them round to the minimum point, as does this one, but unfortunately the stepper board doesn't die off to nothing. It has a small residual amount of movement, which is a bit annoying because it creeps a little bit after you've reduced the speed to nothing, and you have to make sure you do turn it off. So I think that's enough now to consider just showing you how simple this all is. I've got a overhead light which I've fitted up, which is a ring light underneath here, and it illuminates that very nicely. I don't have to have any other kind of illumination. Now I'll move the camera and set up over the top so you can see how the threading works. Now I'll film cutting thread from the end there so you can see what's going on, and then I'll turn the camera around again and film it so that you can see what the display shows. So I'll switch everything on. And push forward the tool, and I'm going to cut a thread along this section here, and the software will, I programmed it, tell me when to stop and when to move in each direction. Now the software only works when the lathe is running, and I'll set the spindle going, and I'll turn at about 300 RPM, perhaps a little faster, 320 say. So I press on the button on the menu to move it in this direction, and it stops when it gets to the point. And I need to start again, forward, and I just make this go in 0.1. It's got to be a total of almost 1 millimeter of depth of cut. I've just reduced the depth of cut to 0.05. I'll just see that's just over 0.9 of a millimetre in, and that should be quite close to the depth of cut I need. It's just starting to go on. Need a little bit more. Try that thread again. just give it a couple of spring passes. There we go, and that's it. The thread's cut, and reasonable fit. It's not as tight as it could be, but it's a good fit. So that's turning a 1.5mm thread pitch. So I'll film this now from the side so you can see the software. I've now transferred across to the other side so you can see the software. The chip is contained inside this box here, which is almost as deep as the box behind there, and it's fed through from the back, so I can display everything with a reasonable chance of sealing it against any swarf and so on getting in. The main menu is on the front, and you can go to two different modes, which is either threading or turning, and I'm going to be doing threading. So if you go down there, you get the thread length that you want to set, which is in my case 15mm. And I'll just run through these. Then the lathe parameters are here. I can change the direction of travel if I need to. The number of teeth on the encoder and the teeth on the spindle are the two things here. If that's 48 on the spindle and 30 on the encoder, and they're joined with a toothed wheel, tooth belt, and the lead screw is a 10mm lead screw. And the encoder's a 1000 encoder, and the pulse per revolution is 6400, and that's the software version number. So if I exit that, I'm in thread cutting, which I want. I exit that, and then on this screen you can set what depth of cut you want to make, whether it's 1.75, 1.5, 1.25, and it puts a note up here as to what it might be used for. That's used for M5, a standard pitch thread that is, and that's M4. So if I go up to M10, so that's the nut that I'm using is an M10 nut. And this is a 10mm bar or rod. Okay, now at the bottom, that flashing symbol means that the next travel is going to be in this direction. I have to start the lathe. I've pushed the tool forward into its forward position to do the cutting, and then I press that, and it stops at the point where it's finished the cut. Retract it, put it back to the beginning, and then I advance the tool and you can see it doesn't tell me how many cuts I've got to do. I need to know that myself, so I need to know how many. This is on the cross slide here. It's a 1mm pitch thread, which is very helpful, so that I know that if I've got to go 0.9, I look at 0.9 on the dial, and that will tell me what to do. So if I go there, 2, I give it a spring pass every once in a while just to make sure that it's gone through the full depth of cut. And you can see the little arrows there tell me which direction to go in, so it's not easy to get lost on what you're supposed to be doing. It's very straightforward. Just do a test fit now. That's gone in 0.9. Oh, that's there now. It's a bit tight, but it is there. Just give it a couple of spring passes. Perfect. So that's the thread cutting. So you can see the kind of thread it's cut.